Hi, I'm Professor Lauren O'Connell, and today we're going to show you how to do a chemotaxis assay with C. elegans. First, obtain some chemotaxis plates and assay templates printed on transparent paper. Cut out the template and tape it to the bottom of the plate, which is the side with agar. Tape the template on the sides so the bottom of the plate is clearly visible. The template divides the plate into 4 quadrants. X marks where the solvent or vehicle control will be located, while E marks where the experimental compound will be located. Worms will be placed in the center. Label the plates on the bottom side. Labels should include the worm strain, compound, and experimenter initials. Next, place the compounds on the plates. Wear gloves to protect your hands from chemicals. Pipette the experimental compounds and the solvent controls onto the appropriate locations on the chemotaxis plate. Take care to match the appropriate compound to the appropriate plate. Pipette 5 microliters of each liquid onto the appropriate location, with the experimental compound in each of the E quadrants and solvent in each of the control quadrants. Place the lid on the plate and incubate for 30 minutes to allow a chemical gradient to establish. During the incubation, we will prepare the worms by removing them from the plate. Wipe your bench with 70% ethanol and obtain some microcentrifuge tubes. Mark the 0.1 milliliter line on the tube with a Sharpie and label the tube with the worm strain and experimenter initials. To harvest the worms, use a P1000 micropipette to add 1 milliliter of chemotaxis buffer to the worm plate. Tilt the plate to allow the buffer and suspended worms to collect at the lower edge of the plate. Pipette the solution up and over the plate again until the worms are in solution. Repeat twice to get as many worms off the plate as possible. Then pipette all of the buffer and worms off the plate and into the pre-labeled microcentrifuge tube. Wait 2 minutes for the worms to settle to the bottom of the tube. Next, the worms need washing. Carefully remove 200 microliters of the buffer from the tube in batches. Try not to disturb the worm pellet at the bottom of the tube. Discard the liquid in a liquid waste container. Gently add 900 microliters of chemotaxis buffer and repeat the wash 2 to 3 times. After the final wash, leave roughly 100 microliters of buffer on top of the worms. Next, set up the chemotaxis assay. This step should be performed in a fume hood with appropriate personal protective equipment like gloves and goggles. Add 2 microliters of sodium azide to each of the 4 compound spots on the plates. Change the pipette tip each time and discard the tips into a hazardous waste bin. Be careful not to pipette sodium azide into the center circle, as this will paralyze the worms. Next, add the worms to the center spot of each chemotaxis plate. The goal is to add at least 100 worms to each plate. Confirm the worms are alive by carefully looking at the plate with a dissection microscope. Incubate the plates face up and lid on at room temperature for 30 minutes undisturbed. After 30 minutes, count the number of worms in each quadrant with a clicker while observing the plate through the dissection microscope. Do not count the worms in the center circle. If the plate has more worms in the experimental quadrants compared to the solvent quadrants, this indicates an attraction to the chemical stimulus. If the plate has more worms in the solvent quadrants compared to the experimental quadrants, this indicates the compound is repulsive to the worms. If the worms are equally distributed across the 4 quadrants, this indicates the worms are indifferent to the stimulus. This data can be visualized by calculating the chemotaxis index, or CI, which is the number of worms in the 2 experimental quadrants minus the number of worms in the 2 solvent quadrants divided by the total number of worms on the plate. This total does not include the worms in the center circle. When visualizing the chemotaxis index, positive values indicate attractive compounds, while negative values indicate repulsive compounds.